is, the definition I like is, it's anything that causes an acceleration. So gravity is a perfect example of a force. So right now I'm holding this, but gravity is pulling down. If I let go of it, gravity forces it to accelerate. It's accelerating at negative 9.8 meters per second until it falls down on the ground. So anything that causes a force, causes something to move, causes an acceleration, is a force.
Okay.
So there's 3 laws governing forces. Do you know what those are? Have you heard of those before?
Some guy named Newton?
Yes.
Something like that?
Newton's 3 laws. So, his first law. What's his first law?
It states that it's often stated as an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force.
Okay, so what that means is my roller skate here is not moving, and it's going to continue not moving unless I apply a force to it. So if I apply a force to it, it's going to move in the same direction until another force acts on it.
So that bowling ball acted as a force.
And also gravity is acting as a force and slowing it down. But it's going in the same direction until it encounters another force.
Okay.
Okay? So what's the second law of motion?
It stated the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object.
Okay, so that is a big mouthful of saying that force is equal to mass times acceleration. Okay, so we know the acceleration due to gravity is negative 9.8.
Yes.
So if I drop this marble and I drop this bowling ball, they're both accelerating at the same rate, even though they have different masses. But if I drop this bowling ball from this height, it's going to make a loud bang. If I drop this marble from the same height, it's going to make a little plink. This dropped with a lot more force because it has a lot more mass. So force is mass times acceleration. Since there's a lot more mass here, it made a big bang versus a little plink.
Okay.
Okay. What's his third law?
His third law states that for every action there is an equal and opposite reaction.
Okay. So that means whenever 2 things collide, or whenever 2 things hit each other, if I apply a force in one direction, there's an equal and opposite force in the opposite direction. So if I hit this roller skate with my ball here, the tennis ball went back this way because as it hit, there was a force pushing the ball back in the roller skate this way. And we've got a really good video clip to show you, so I'll show you that clip right now.
One of the things we study in physics is the interaction between objects. Check out this interaction between these objects. Great job, guys. Now, who felt a greater force in that interaction?
Well, I guess I did.
Well, actually, according to Newton's third law of motion that states for every action there's an equal and opposite reaction, you both felt the same force. Let's demonstrate with the scales. Now, it's safe to say you're stronger than me, right?
Yeah.
All right. But it doesn't matter how hard you pull. On your scale, my scale reads the same number. What's true for pulling is true for pushing. You and Corey felt the same force.
Well, how was I be able to blow him off the line?
Well, there are other force pairs involved, namely between you and the ground. You push it against the ground and the ground pushes you forward. If you push the ground harder than the other guy, you move him back.
Cool. So I guess that's why Coach tells us to keep our feet moving.
Exactly.
All right, let's demonstrate that.
Whoa, wait a minute.
Okay, and now we've got one more demonstration. Some of these laws can apply at the same time. So I'm going to combine the second and third law here. So what's going to happen, I'm going to drop both of these balls at the same time, and as I drop them, they'll both hit the ground, and then the force from this ball is going to cause the marble to jump up in the air. So what happened there, they had an equal and opposite reaction. So whenever this one hit and bounced back up with its force, the marble's force pounds down, they had an opposite reaction, causing the marble to shoot back up quickly.
Okay.
Okay, and that's it.